I'm Dr. T and welcome to my office. So today I'd like to do something a little bit different and build a circuit and talk about circuits. So I'm going to be starting out and I'm going to need a couple of tools for this, making sure the GoPro's got in the right spot. This is a multimeter, so it's going to be able to measure quite a few properties. Voltage is what I'm going to be looking at. So of course I've got the leads. Your model will vary, but they're all fairly similar. Make sure, read the manual. Dashed line means DC, wiggly line means AC, V is for voltage, omega is for ohms. This is going to be the resistance. How much does the material either insulate or does it resist the flow of electricity? And then A is for amps. I'm usually dreadful in getting any of these guys to work except for the voltage, so we're going to work on voltage. Okay, so I'm going to take a couple of batteries here. I'm going to turn this guy on, and what I want to do is set it so it's in about the right range. So I know that this battery at least is supposed to give me about 1.2 volts. So I'll put this guy on, and I'm going to touch the bottom part of the battery. Let's see if this, there, I want to see what's on the camera. So I'm going to touch one lead to the bottom part, one lead to the top part. Okay. So right now I'm actually going to switch the setting up. So this is now single digits. And I get 1.29 volts. Now the reason why it's negative on that is because I've actually got my lead switched. The red is positive and I put that on the negative, and the black is negative and I put that on the positive. So if I get that in the right order, boom, I got call it 1.3 volts, assuming I can actually keep the thing on the battery. Okay, now I can use this to test batteries if I'd like. So I've got over here a pair of 9-volt batteries, and I happen to know that the Duracell over here happens to be a little bit older than maybe is optimal. So let me try this. First, I'll go for this Rayovac. I poke him on the two leads. I get 9.5 volts. Okay, he's probably good. Now this Duracell expired 6 months ago, so not putting this in anything. Let me go ahead and poke the leads onto it. Obviously I've got them switched, so let me switch the sides. I'm getting 8 volts. As batteries get consumed, their voltage goes down. So they're not able to push the electrons through the circuit as well as they used to. So this battery is time to go away. I have to figure out where to recycle him. Okay, so let's look at a couple other things when it comes to batteries. So originally I had one AA. I'm going to grab a second AA. They've got hiding on those legs. And I'm going to show you something rather interesting with voltage. Make sure the GoPro is going. Using my thumb to lock that in place. Then, using the other hand to lock that in place. And now I'm going to touch this mess together. Wow, that's not working. There we go. Okay, so now I'm getting 2.5 volts. Well, remember, each battery was 1.2, 1.3 volts. So let's call it 1 1/4. 1 1/4 plus 1 1/4 gives me 2.5. When I put batteries in this configuration, this is what we would call series. When I put them in series, they're going to add together. Now, if I were to put them, kind of in this configuration, and I can't do this with my hands, but if I were to somehow, line them up like this, which, once again, these, I'm not going to be able to do it, I would still see the same voltage. I'm going to have more current that I can draw. I've got double the power sitting here, but I'm not going to be able to have more oomph per electron. Whereas if I put them in series, I can get enough oomph per electron. And this is why I might care about voltage. So I'm going to put those aside, and I'm going to bring up my friend, the LED. LEDs basically work like solar cells, except for the fact that they do exactly the opposite. They take electrical power, shuffle the electrons through them, and in the process they take some of the energy from the electrons as it's transitioning from one part of the LED to the other, and that it comes off in the form of light. Solar cells do the exact same thing, just in reverse. So the relationship between an LED and a solar cell is the same as a windmill and a fan. Okay, so now I've got my LED, I've got my battery, I put them together, and nothing happens. Now, with LEDs, I could have the battery in backwards. That's entirely possible. So let's try this again. Nothing happens. Maybe the problem is I only have one battery, because remember, that was 1.2 volts. So over here, let me get the voltmeter out of the way, I have a battery pack. And if you look at this guy fairly closely, and I'll use one of these leads from the voltmeter to point out, this battery is going one way, this battery is going the opposite way. This is very, very common. Now, if you look at the battery pack, right in here, see what the GoPro can see. If you look right in here, there's a piece of metal. Why don't I take out the batteries? So if you look in here, there's a single piece of metal down here. So this is directly connected to that. If I look at the top, I have two different pieces of metal. This piece of metal is attached to the red wire, this one's attached to the black wire. Typically red is going to be positive, black is going to be negative. So now, why don't I put my batteries in, and this is going to do the same thing that I clumsily did earlier by now holding to the two batteries in series. So now they're in series, and I cannot remember which leg of this LED goes which way. So I'm going to plug one into one end. I'm going to plug the other end to the other end. There's a tiny little mark on the LED. Okay, and hey, it's illuminating. I'm hoping you can see that on the camera. So now the LED is illuminating. Great. If I were to switch the two legs, then the current would be going in the wrong direction. LEDs and a lot of your electronics are very sensitive to the polarity, which way the electrons are going, and notice how it's not illuminating. Whereas if I switch them, it illuminates. Now, this actually gives me a couple of useful features that I can do. For starters, this allows me to see what's taking place with this one. So I can see the current flow. The other thing that I can do is I can use this as a quick little demo to look at things that are insulators versus conductors. And to do that, first I'm going to disconnect this so that I'm not continually using my batteries up. Kind of move this off to the side. Okay. And what I want to do is go fetch a couple of things to work with. Okay, I'm back. I have a screw and a balloon. So one of these is going to be a conductor, one's an insulator. And obviously, you know, if you're teaching little kids, this would be great, you know, just grab a bunch of things. Now, when I'm working with this one, the voltage is going to be determined kind of by your batteries. It's chemical reactions that are generating the voltage. Now, with the LED, obviously he's sensitive to the voltage. As he's working, he's drawing current. The amount of current he is drawing describes by how much he resists the flow of electricity, its resistance. So the voltage is going to equal the current, which is given the letter I for some reason, and then the resistance. So how much this guy is resisting the current's flow. What I don't want to do, and with these low power batteries, it won't hurt anything, but what I don't want to do is touch the two together. The wires have very, very little resistance. This is going to allow a lot of current to flow very quickly because that resistance would be very low, and this is what's a short circuit. Once again, with 3 volts in batteries, it's not going to be a big deal if I were to actually touch them. See, not much, although I think you might have seen a spark there. Now, with these guys, what I'm going to do, traditionally, we do anything interesting on the black side. The return is usually left kind of benign. You know, we just let that go straight back. So now I'm going to grab another wire. And I'll plug that in. Alligator clips, something you can grab on Amazon. They're pretty cheap. And I'm going to stick something in between them, like this screw. And lo and behold, the electricity is going through the screw, and the LED lights up. Yay! And take this apart. And instead of putting the screw in there, I can put the balloon in there, and lo and behold, it doesn't light up. So the balloon is a nice conductor, or sorry, the balloon is a nice insulator. The screw is a nice conductor. You'll notice how it's not lit up when there's nothing attached. Air is an absolutely dreadful conductor. And I should also point out, just a reminder, that both ends are important. I'll get back here. So I'm going to connect those, and I'm going to disconnect the return. Because the common analogy is to think of this like water. Water doesn't need a return, but notice the return is disconnected, but the LED is off. So it's getting the electrons, but it's not able to send them back. They don't flow through. You have to actually plug the thing in. Okay, so nice little demo you can do. With that said, everything you need is generally available on Amazon. Old Radio Shack was the place to get this stuff, but they're deader than a doornail. So this is kind of, grab the internet wherever you'd like. If you want to grab any of this kit, it's a nice little fun demo, and have a wonderful day.